Okay.
I think a draft card IFTS.
So let's talk about the synthesis of water. All right.
Yeah, that one was kind of, all of them were kind of confusing. I failed that.
So number 7, it says suppose 3 tubes are filled with a mixture of hydrogen and oxygen in a manner similar to that used in Figure 6.2. The tubes contain the volumes of hydrogen and oxygen. The tubes contain the volumes of hydrogen and oxygen shown in the table below. After the mixture in each tube has been ignited, which of the following represents the volume and the identity of the reacted gases in tube 1, and tube 2, and in tube 3? So, the whole idea is, what you learned in the decomposition of water is when oxygen and hydrogen are broken down from water, you get twice as much hydrogen as oxygen. Same thing happens when you react hydrogen and oxygen. So if we look at this, let's just cover up this side. If we have 25 cubic centimeters of oxygen, how much hydrogen would you need to react with that? 50. Do we have 50?
No.
We have above 50. So 50 of this is going to react, and 25 is going to remain unreacted. So the answer to tube 1 is letter C. So on number 7, you should have tube 1C for the answer. On tube 2, we have 50 of oxygen. How much hydrogen would you need? 100. We don't have 100, so let's look at it the other way. 50 of hydrogen needs how much oxygen? 25. Do we have 25? Yes, we have above 25. So 25 is going to react, 25 is going to be left unreacted, so the answer to tube 2 is A. And then in tube 3, we have 25 of oxygen and 50 of hydrogen. That's a perfect 1-to-2 ratio. So we're going to have no unreacted gas, letter D, on number 3. Okay? So let me move this up a little bit. And let's talk about 8. 8's a little bit more complicated than number 7, right? Would you agree?
I got crazy big numbers for 8.
Okay, which you should. So 8 says if 18 grams of water is decomposed into hydrogen and oxygen, by electrolysis, 16 grams of oxygen, 2 grams of hydrogen are produced. Does it make sense that 18 grams of water would turn into 16 plus 2, which is 18 grams of gas?
Yes.
Yes, because mass is conserved. So whatever you start with, you end with. So using the densities in table 3.1, which we gave you in the decomposition of water, those densities, find the volume of water decomposed. So on 8A, here's the equation. M is equal to V times D. The mass is 18 grams. What's the density of water?
0.0. No, water.
It's 1. Water's 1. So divide both sides by 1, and you get the volume is 18. The nice thing about water is, whatever its mass is also its volume. Okay? So you don't even have to calculate it. Then on B, they want to know the volume of hydrogen produced. Well, we have 2 grams of hydrogen. So I'm going to use the same equation. M is equal to V times D. 2 is equal to V times 0.000084. How are you going to get that to the other side? Anybody in an algebra class? Divide both sides by 0.000084. Okay, and you end up with, I'm going to round this, 24,000 cubic centimeters. So 2 grams of hydrogen would have a volume of 24,000 cubic centimeters. Now, they don't ask about oxygen, but what volume do you think 16 grams of oxygen would have? Using what we learned in number 7.
Oh, I think I got like 32,000 for that.
For the oxygen?
Yeah.
Well, you didn't have to do it, because it doesn't tell you to.
Yeah, I did oxygen instead of water.
Okay.
The volume of oxygen.
Okay. But if the volume of hydrogen is 24,000, the volume of oxygen would be 12,000. Okay? It'd be half as much. So we didn't have to calculate it. And if you think about it, let's just compare the two volumes. If you add 12,000 and 24,000, you get 36,000. So this 18 cubic centimeters of water turns into 36,000 cubic centimeters of gas, which we talked about yesterday, or I think it was yesterday. Volume is not conserved. Mass is conserved, but volume is not. Gases take up, in this case, over 1,000 times more space than the liquid they came from. Okay? So let's turn the page and look at number 9. I have to do some rearranging here. So 9 says, suppose you were not told the identity of the gases remaining unreacted in the experiment shown in figure 6.2. Suggest a line of reasoning that would lead to the conclusion that the remaining gas in part A is oxygen and in part C it's hydrogen. So let's look at figure 6.2. That's this right here. And let's just take them one at a time. I'm going to have to erase the previous answers. Okay, good enough. So just like number 7, one volume, which it doesn't matter what the units are, 1 V of oxygen needs how much hydrogen? 2. We don't have 2, right? So let's work it the other way. 1 volume of hydrogen needs how much oxygen? A half. And so what do we have left? Half. So here's what I'm going to say on 9A. 1 V of H, 1 volume of hydrogen, I'm going to shorten that, reacts with half a volume of O, leaving half a volume of O unreacted. So that's what the unreacted gas is, half a volume of O. Why don't they ask about B? There's no gas left, so we don't care about it. So let's move it down to C, maybe. Now we've got 1 volume of O. How much would that react with? 2. And we've got 2, right? So we're going to, 2 of that's going to react, 1's going to be left over. That's what the 1 volume of gas is. So on B, we don't need to move this. No. This way. Actually, not B, it's C, isn't it? So on C, we'll do the same thing. 1 volume of O this time reacts with 2 volumes of H, leaving 1 volume of H unreacted. And so I'm going to turn the page so we can look at 10 and 11. Also, so number 10, Addie, can you see that okay? Okay. I'm going to erase 9. Can I? Actually, I'll put 10, I think. I can put 10 up here and then I'll erase 9. So number 10, suppose you mixed 100 cubic centimeters of oxygen with 200 cubic centimeters of hydrogen. That's a perfect ratio, right? So there's not going to be anything left unreacted. The volumes of both gases are measured at atmospheric pressure at 20 degrees Celsius. The reason why they tell you that is because gases expand greatly when they're heated, okay, and when pressure changes. So the 24,000 cubic centimeters of hydrogen we got previously, if you increase the temperature, that might turn to 30,000 cubic centimeters, okay? Or if you increase the pressure, it might decrease down to 10,000 cubic centimeters. Solids and liquids don't vary by very much. So A, it says calculate the mass of oxygen and the mass of hydrogen used. So here's the equation. M is equal to V times D. So for O, all we have to do is take, say, M is equal to 100 times the density of O, which is 0.0013. That's easy math. It's 0.13 grams. And then for H, M is equal to 200 times 0.000084. Anybody have that number, or do I need to calculate it?
It's 0.00168.
Okay, I think it's 0.0117 is what I'm going to call it. 0.017. Okay, so I'm going to round that to 0.017 grams. So that's A. On B, put B up above it. Says if you ignited the mixture, what mass of water would result? We know mass is conserved, so this is our these are our masses. We just have to add these together. So 0.13 grams plus 0.017 grams is equal to 0.147 0.147 grams of water. In other words, M of O plus M of H equals M of H2O. And then on C, what volume of water would be produced? Do we need to calculate that? We just said the density of water is 1, right? So it's 0.147 cubic centimeters.
That's if the water was a liquid, right? 0.147 centimeter squared.
Yeah.
Okay.
Yeah.
Because if it was a gas, it'd be a lot bigger than
Right.
that one.
And if it was a solid, it would be bigger than that too. Okay. So number 11 says if in problem 10 you'd used 100 cubic centimeters of oxygen, which is what they had, but only 50 cubic centimeters of hydrogen, what mass of water would have reacted or would have resulted? So in this case, 50 cubic centimeters of hydrogen would need how much oxygen?
25.
25. So not all of that is going to react. And so what I'm going to do here is I'm going to just change this number to 11. We are going to have to figure out, plug in some different numbers here. So we have 25 of oxygen and 50 of hydrogen. And then I'm going to put a part B here, which we'll just add these together to figure out the mass of water. So 25 times 0.0013.
0.0325.
0.0325, so I'm going to call it 0.033 grams. And then for hydrogen,
0.0042.
0.0042 grams. And so we could just take 0.033 plus 0.042, 0042, so. And you get 0.0372. 0.0372 grams of water. Now that's the hard way to do it. There's an easier way to do it. Anybody figure it out? Well, all that we did here is when we went from 200 to 50, we reduced this by a factor of 4. This one went from 100 to 25. That was reduced by a factor of 4. So the mass is going to be reduced by a factor of 4. So if you take 0.147 divided by 4, you get 0.03675, which is very, very close to that. So that's just rounding is what we got there. So any questions about that? Okay, so on Canvas, there's a quiz for you over the synthesis of zinc chloride lab. So take a few minutes, take that quiz, and then write this in your comp book. This is a lab we're going to do today. A reaction with copper. And Addie, I've got a YouTube video attached to this reaction with copper you can watch and answer the questions for, okay? So, are you good? Can I dismiss you? Can I let you go?
What was the answer to 10B?
0.147 grams. Any other ones you need?